We've used retrievers in every lesson. Now let's open them up, because under the hood there are several very different architectures. And they all differ on one single question. At what point do the query and the document actually compare? Answer that one question 3 ways, and you get the 3 main architectures. A bi-encoder compares them just once, at the very end. A cross-encoder compares them fully, from the very start. And ColBERT's late interaction sits cleverly in between. Behind that one question lies the central trade-off of all retrieval: speed versus accuracy. Start with the bi-encoder, the workhorse of dense retrieval. It has 2 separate encoders. One turns the query into a single vector, the other turns each document into a single vector. Here's the crucial part. Every document is encoded ahead of time, offline, and stored in the index. The query is the only thing encoded at search time. So the actual comparison is just one dot product between 2 vectors, which is why it scales to billions of documents and answers in milliseconds. But there is a cost. Each document is crushed into one single vector, and the query and document never truly meet, so fine-grained matches, a rare name, an exact phrase, can get blurred away. This is the representation bottleneck. The cross-encoder takes the exact opposite approach. It glues the query and the document together and feeds them through one transformer, so every query word can attend to every document word all at once. All that interaction makes it remarkably accurate, but it outputs only a relevant score, not a reusable vector, and nothing at all can be pre-computed. You would have to run the full model on every single query document pair. Across 1 million documents, that's 1 million forward passes for one query, completely impractical. So a cross-encoder can't be your retriever, it can only re-rank. And that gives us the standard 2-stage pipeline. A fast bi-encoder retrieves the top candidates, and then the slow, accurate cross-encoder re-ranks just those few. Bi-encoders are fast but coarse. Cross-encoders are precise but unscalable. ColBERT asks, can we have both? Instead of 1 vector per document, it keeps 1 vector per token, for both the query and the document. And, just like a bi-encoder, those document token vectors are computed offline and stored. The magic happens at query time, in what's called late interaction. For each query token, it finds its single best matching document token, the maximum similarity, and then sums those maxima across the query. That operator is called maxsim. This recovers fine-grained, token-level matching, much of a cross-encoder's accuracy, while keeping documents pre-computable, much of a bi-encoder's speed. Its one real cost is storage, many vectors per document, which ColBERT v2 tackles by compressing each token vector down to a centroid plus a tiny residual, shrinking the index 6 to 10 times. Everything so far has been dense, neural embeddings that capture meaning, but there's a second, completely independent axis. The old guard is sparse, lexical retrieval, like BM25. It matches exact words, scoring each document by the query terms it literally contains. And each one shines exactly where the other fails. Dense retrieval knows that car and automobile mean the same thing. Sparse retrieval nails an exact product code or a rare surname that an embedding would smear together. Learned sparse models, like Splade, blend the two by using a neural network to predict weighted, expanded keywords. And in practice, the strongest systems simply run both, dense and sparse, and fuse the results. That's hybrid search, and it's the default in serious production retrieval. So here is the whole landscape. One axis is interaction depth. Bi-encoder, late interaction, cross-encoder, running from cheap and coarse to expensive and precise. The other axis is what you actually match on. Dense meaning, sparse keywords, or a hybrid of both. A typical strong stack looks like this: hybrid retrieval to gather candidates fast, then a cross-encoder to re-rank them precisely. And you reach for ColBERT-style late interaction when you need fine-grained matching, but simply can't afford a cross-encoder over everything. Because in the end, every retrieval architecture is just one answer to a single question. How much can the query and the document afford to interact?